going on page 54 when we're done. Now, when I wrote this out on paper, my blanks were plenty big enough, so hopefully they're big enough for you. However, with these boards, I cannot write very small, and so the blanks are not big enough when I write on the board, so just bear with me here. So a sequence is a function from the whole numbers to the real numbers. Okay, so a sequence is a list of things that we're going to end up with. Sequences and series are often done together. A series is when you sum up your sequences. We are not going to talk about series right now. We're just looking at sequences. But what this means that from the whole numbers to the real numbers is your inputs to your outputs, basically. So our inputs, unlike all the other functions that we have done, cannot be decimals. They can't be negative numbers. It has to be 0, 1, 2, 3, 4, something like that. But our outputs are just in the real number system. So I can have 1/2. I can have -2, things like that. But I cannot input a negative number or input a fraction or decimal of any sorts. Okay? So that's, I think it goes along to say this. This means that we are only able to plug in whole numbers. So here are your whole numbers, 0, 1, 2, 3, 4, into a sequence. But we can get any real number as an output. Okay? So it's not like it just outputs whole numbers. As a result, when we graph a sequence, we will have points, but we cannot connect them. Okay, so even though it's a function, this is discrete data, which means when we plot our points are our points. We're not connecting the dots in any form or fashion. Okay? It might look linear, but we don't actually connect them to make a line. So we consider a sequence defined by this. Now notice this looks linear here, but this does not say y equals. It's different. That a sub n, that means we're just getting like one little output here. Find a1 and a7. So that means a sub 1 is equal to 4 times 1 minus 3. That is super easy. I will give you that. But you cannot just write the answer. You absolutely have to, at the very least, substitute it in, 0 work. And then if you don't show any more steps, that's fine. 4 times 1 is 4, minus 3 is 1. There's no reason to show anything else. But first step, 0 works, substitute it in. Okay, that's a habit you really need to get into if you're not already there. Then a7, that's going to be equal to 4 times what? 4 times 7, right, because that's my little subscript, minus 3. Now, if you want to write intermediate steps like 28 minus 3, totally fine, but you don't have to. 28 minus 3 is 25. Okay? Easy enough there? Okay. So we have 2 types of sequences that we're going to look at. Arithmetic sequences, which is what we're looking at today. Geometric sequences, which is what we're looking at tomorrow, which will lead us into the next thing that we are doing. So for arithmetic sequences, here's the property of successive terms, meaning the terms that come one right after the other. Successive terms have what's called a common difference, and your common difference is shown by the lowercase letter d, which basically means your constant rate of change. Okay, common difference, it's a constant rate of change because it can look, that means that the arithmetic will look linear, but again, no connecting the dots. You are given 2 formulas or equations here. Again, you are not actually given any formulas. I don't know exactly how this will look on the AP exam. If it will be it shouldn't be in the free response. It'll be multiple choice of some sort, but you're not going to be given the formulas. But we'll look at how, once we get a little farther into this, how the questions are going to be asked. But if you're only going to know one of them, the second one is the more important one because it's the one that will work for everything. But you'll see even as we go through today, if we know this one and we can do this one's going to start to make sense and you're just going to know it as well. That's just kind of learning by doing, not necessarily a memorization thing. All right, so in these formulas or equations, a sub 0 is the initial value. Okay, your initial value, where it starts when you substitute in 0, this is what you're going to get. D is the common difference. And again, sorry, I cannot write small enough on this board to make this fit. Difference. Maybe I should start writing things out on the board and on the paper to make sure they fit. And then a sub k, that is what is called the kth, and that's a lowercase k, kth term. So if it's a sub 4, it's the fourth term, fifth. So kth term, I know sounds very strange, but it just means what it means. It's not that big of a deal. Okay, so some little notes about this. Arithmetic sequences behave like linear functions, except they are not continuous. So once again, we are not connecting the dots. Increasing arithmetic sequences increase equally each step. That means the slope stays the same. That's where your constant rate of change comes in, right? Your common difference, constant rate of change type of thing. Okay, everybody okay with that? Okay, good. So let's look at this little example, and we have a little graph here. So we have a sub n equals 3n plus 1. So again, looks like the equation of a line, except that's not an x, it's an n, and that's not a y. So that's how we know we're not actually connecting all of that. We are going to make a little t-chart over here. It has n and a sub n. We're going to do 0, 1, 2, 3. And of course, it would keep going, but I don't get to use any negative numbers. 0 is where I start. So then if we needed to show some work, we could, but this is super simple, so we don't have to necessarily show that we're substituting it in a situation like this. When I substitute in 0, what do I get? 1. When I substitute in 1, what do I get? I substitute in 2, I get 7, and 3 gives me 10. Okay? So let's go plot those. At 0, I'm at 1. At 1, I'm at 4. At 2, I'm at 7. At 3, I'm at 10, but that's off my graph, so I can't actually do that one. Do I connect these dots? No, I absolutely do not connect these dots. When I look over here, my common difference, is it 3 or negative 3? 3. It's because I do 4 minus 1, that gives me 3, 3, 3. Just like we did before, those are our first differences. It is a common difference. So that tells me that D equals 3, which we actually already knew, because if we look at this and this, I can see from this form right here, if I just looked at this and hadn't done anything else, that a sub 0 is equal to 1 and D is equal to 3. And look at this. My initial value is 1. My common difference is 3. And that's what that form tells me right there. Okay, we good with that? So your initial value is like your y-intercept. Your common difference is like your slope. Right? But again, this is why we looked at like the A and B thing and not really the mx plus b on the calculator as well. We all good at this point? Okay, super easy. You just got to know how it works together and what parts we're looking at here. Okay. So for each of the following, we are going to determine if the sequence could be arithmetic. If yes, we're going to identify the common difference. So I'm going to try something a little bit different here because room and writing this down is a little bit of an issue here. Now I made our t-tables vertical over there. What you see a lot in the way AP does, and I don't know if they're doing it to save room or if it just makes more sense this way, but if you've noticed in the tables of data that we have had when we were doing it on the calculator, everything was horizontal and not vertical, right? So we're just going to do ours horizontal because that'll help us save some space here, and I'll show you what I mean by that. So like this would be N, and this would be S sub N. We're going to do a horizontal table instead of a vertical table, but it works the same. When you do this, your x's are on top instead of on the left, or what acts as your x. So we've got 0, 1, 2, 3, and it will keep going. So when I substitute in 0, what am I going to get? -3. When I substitute in 1, what do I get? -2. Do I wish I had spaced my numbers out better? Yes, I do. When you substitute in 2, what do you get? 1. When you substitute in 3, what do you get? 6. Okay, and then that would keep going as well. Okay. So if you didn't space yours out well either, it's okay. We'll do better on the next one. All right, so then I'm going to look at, I'm sorry, I don't even know if I read the question here. For each of the following, determine if the sequence could be arithmetic. If yes, identify the common difference. If you can tell by looking, great, congratulations, nobody cares. If you do not have evidence, it does not matter what you can tell by looking, okay? This is part of my evidence, right? And then I'm going to look at my common differences here. What is the common difference here? 1. What is the common difference here? 3. Therefore, I don't have to go any farther. I could, but I don't need to. Because if I had a common difference, those two numbers would be the same, right? And they are not. So then I can answer the question and say, this is not arithmetic. No common difference. Ooh, I can't spell. Difference. So this is me answering the question, not arithmetic. This is my reason why. This is my evidence to my reason why. Okay, we good on that? Any questions? All right. So let's do B, and I'm going to space things out better over here. So this is N. This is S sub N. 0, 1, 2, 3, ... So when I substitute in 0, what do I get? 6. 1 gives me 4. 2 gives me 2. 3 gives me 0. Again, if you can tell by looking at this point, congratulations, nobody cares. You have to have evidence. All right? So then my common difference here is what? -2. Here is -2. Just doing those two, not enough, because it's possible that those two are the same and then it goes off the rails, right? So I do it again and I get -2. Then I can answer my question after I answer the door. Oh, okay. Wait, what? But why are some of them attached to other things? Okay. Okay. Thank you. Okay. So then here, I'm going to say that it is arithmetic. And D equals what? -2. Okay? All right, so then C has my data already. I'm not having to find it, but I have to look for common differences here. So what is the common difference here? 5. What about here? 5. What about here? What about here? All right, so is it arithmetic? Yes. So then I can say arithmetic and D equals 5. Everybody okay with that? All right. So then here, what is my common difference? What's my common difference here? 5. Do I need to go any farther? No. Should I double check that I subtracted correctly? Probably. But we did. That's fine. So that I can say, again, not arithmetic. No common difference. Everybody okay with that? Any questions at all? Okay. All right, so let's flip this over. And then we're going to rewrite our formulas from the front up here at the top here. So we have a sub n equals a sub 0 plus d times n. We also have a sub n equals a sub k plus d times n minus k. So let's read this question. It says, let a sub n be an arithmetic sequence with a sub 3 being 8 and d being equals to -3. Find an expression for a sub n. So I've got two things to do. I'm going to find an expression for a sub n and use the expression to find a sub 12. So basically there are two parts to this answer. You have to have an actual equation along the way. Office next hallway, she's in 110. Okie dokie. All right, so I'm going to start off now. I don't know the initial term, right? So that formula, not going to help me. So I'm going to use this formula here where I have d, right? Gives me that right there. A sub n, obviously I don't know because I don't have an expression for that, which means that this little guy right here, he's going to have to be a sub k, right? So what does a sub k equal? 8. A3, which is 8, right? What does k equal? 3, right? Because it's a little subscript. So let's think about that when we substitute this in here. So I'm going to have a sub n equals a sub k. So what do I write? 8 plus d, which is -3 times n minus what? 3. And I'm regretting the numbers that are in here now. It's -3 because this is 3, not because that's -3. This -3 comes in right there. This 3 is what goes right there, right? Because it's k. Because of the same number. I don't want anybody to be confused. All right, so then I get a sub n is equal to 8, and then -3 times n is -3n plus 9. So that means a sub n is equal to 17 minus 3n. So this is what this part right here was asking for. So now given that, this question doesn't ask this, but I'm going to ask you, what is the initial term? What is a sub 0? 17, okay? Because this now matches this form of the equation, right? Where a sub n equals a sub 0 plus d times n. So 17 is your initial term, right? Okay, so now that we have that, now we can find the 12th term. So a sub 12 equals 17 minus 3 times what? 12. So that's 17 minus 36. So the 12th term is equal to, is that my answer going to be positive or negative? Negative, and then I can worry about the number. Negative what? 19. Okay. What questions you got? I highly suggest, and you'll see why maybe even more on example 4, that you actually label what you're using these things for so that you don't get the numbers confused. Because there's really nothing crazy difficult about any of this, but easy to mess the numbers up or put the wrong thing in somewhere. Okay, we good? Any questions? Okay. So let's look at this one. A sub n, let a sub n be an arithmetic sequence with these two terms. Find an expression for a sub n. So we're doing the same kind of thing. We got to find this and use it to find the 24th term. So this time we're not given the common difference, which means I have to find it before I do anything else. So I'm going to start off just so that we can see it and we can talk about it. I'm going to rewrite this formula. A sub n equals a sub k plus d times n minus k. And here's a little hint also. the more you rewrite things, like if you rewrote that on every single question you did, before you know it, you're going to know it, and you didn't even try to memorize it, okay? Just looking at it and using it, that doesn't stick in your mind the same way as rewriting it every time. Then you're not even thinking about it when you're writing it. If you trust me on that, that's how you can learn things a little bit better. All right, so before I can do, so in order to write a sub n, I have to have one term and the common difference. I have two terms, no common difference. But if I use both terms, then I can figure out what the common difference is. Does that make sense? So we have these two terms. One of them I'm going to use as a sub n. One of them I'm going to use as a sub k. Makes absolutely no difference which one is which. Just pick it and stick with it. So I'm going to say, let's just use this one as a sub n. And we'll use this one as a sub k. If I knew the initial term, that'd be different. We could use that, but we're just going to go with this. Okay? So then I'm going to take those and I'm going to substitute them into here. What is a sub n? 7. So 7 is equal to, what is a sub k? 9 plus d, which I do not know, times what is n? 2 minus what is k? 6. Any questions about where any of those numbers came from? All right, let's clean this up a little bit. 7 is equal to 9 plus, and then this is negative 4 times d. So this is going to be, well, here, I could do plus, but really I could just do minus or d. It's a little easier. Now, when I was working this out the first time, I got here and I looked at this and I said, all right, well, as soon as I saw 7 and 9, I was like, well, 7 and 9 is 16. When I divide by negative 4, d is negative 4. And I wrote d is negative 4, and I moved on with my life, and then I checked my answer, and I was way wrong. Because what I just said, does that make any sense? No. Do you sometimes, I know some of you are perfect, but others of you are like me and not perfect, mess up? Is this pretty easy to solve? It should be like super easy, right? Is that most of the time where our mistakes happen? On the easy stuff, because we're not paying attention, right? Because we're just trying to, I can skip all these steps. And then when I thought about it, I was like, oh, wow, that's dumb. So you don't have to write down unless you want to or need to, like minus 9, but you need to actually think about the super easy solving so you don't do ridiculous things like me. So when I subtract 9 from both sides, what I really get is a negative 2. And that's equal to negative 4d, which some people will answer as 2, but it's not 2, right? D is equal to what? 1/2. Okay. So we did all of that. We still haven't answered either question, right? I have the common difference now, so now I can write a sub n. If I knew the initial term, which I still don't know and don't really care about at this point, I could use that first equation, but I don't have it, so I'm going to use this part right here again. I'm going to substitute into here. So now a sub n is what I'm trying to write. A sub n is equal to, now I'm done with this one really because I'm not putting a 7 in there. I'm just going to, could I make this a sub k now if I wanted to? Yes, but why complicate things? Just stick with this one. That is equal to a sub k, which is 9, plus 1/2 times, because that's your common difference, times n minus what? 6, right? Because that's your k. Then we just clean this up. This is equal to 9 plus 1/2 n minus 3. So a sub n is equal to 6 plus 1/2 n. So there's my a sub n that I was asked for. So tell me, for this sequence, what is your initial term? 6, right? It's 6. And again, nobody's asking me for that, but something we should be able to recognize. All right, so now I have that. Now I want to find 24 here. So A24 is equal to 6 plus 1/2 times what? 24. So the 24th term is equal to, well, half of 24 is 12, plus 6 is 18. What questions do you have? We good? You see how labeling things so you're pulling the right numbers off of things can be very, very helpful so we don't do weird things. None of this work is complicated. None of it. Are there lots of places that you could make a ridiculous mistake? 100%. Okay, so they just want to be careful when you're doing that. Make sure you're using the correct numbers because that could mess it up too, even if your math is 100% right. All right, we all good? Okay, good deal. So let's look at this one. So it says several terms of the arithmetic sequence a sub n are shown above. Once again, we want to find an expression for a sub n and then use it to find a sub 17. Now on this one, do you know your initial term? You do. Now, and we haven't written down that formula very much, but every time I've asked you, hey, now that we have this, what's our initial term? So by now, it may be no surprise to you that when you have this, you have your initial term plus d times n. If you don't know that formula when you get there, you could use the other one and you could still get your answer, but it's just the initial term plus the common difference times n. So I can write my equation very easily once I figure out what the common difference is, right? Because I have a sub 0. I know that a sub 0 equals what? 8. And then I need the ooh, goodness gracious. I need the common difference. What is my common difference? It is the slope, basically, yes. -2. So -2 or +2? -2. Because I think we could all easily see you've got 8, 6, 4, 2, 0. Clearly the 2 pops in your head. You can look at this and see that your slope is negative. Plus, you're supposed to do 6 minus 8, not 8 minus 6. So d is totally -2. Okay, we all good with that? Okay, so now my actual equation here, a sub n is equal to, your initial value is 8, d is -2, so -2 times n. There you go. Alrighty, then we have a 17. Now just before we even do this, tell me something you know about the 17th term. What does it have to be? Negative, right? Because you can tell once we got to the 4th term where it's 0, the rest of them, because they keep going because it's linear, right? They have to be negative. So if you have that thought before you start, if the answer you get's not negative, you can go figure out why. And maybe it's because you might have chosen a +2 instead of a -2. You can kind of catch yourself on those things, okay? So reasonableness of an answer is always important. So it's 8 minus 2 times what? 17. So this is 8. What's 2 times 17? 34. So the 17th term is a negative what? 26. Very good. What questions do you have? We good? Okay, good deal.